Alright, today what we're going to do is we're going to learn how to solve two-step equations. And before we do that, I just want to review order of operations. So I used the example before of 6 plus 4 divided by 2. And in order to complete this, there's a specific way in which we must do these problems. And if you remember, we used PEMDAS, P-E-M-D-A-S, or please excuse my dear Aunt Sally, parentheses, exponents, multiplication to division, done left to right, and addition subtraction done left to right. Now this is only used for simplifying algebraic expressions. So we'll take 4 divided by 2, which is 2, and then 6 plus 2, and we'll get 8 as our answer. All right, what we're going to want to do today is solve two-step equations, and we're actually going to do this PEMDAS in reverse. So we're actually going to start with addition subtraction, move up to multiplication division, exponents, and then parentheses. And I'll show you an example of what I'm talking about. So let's look at the example 2x plus 3 equals 15. What we want to do is we want to solve for this variable. We want to solve for the x, right? Which means we have to get rid of this 3 and we have to get rid of this 2, but we have to do it in a specific order. And the way we do that order is actually in reverse PEMDAS. So we'll start here and work our way up. So start with the addition and subtraction. So what's being added or subtracted here? The 3 is being added. All right, so what we want to do is get rid of the 3 first, and we're going to subtract it from both sides. Right, we want to maintain this balance between the equal signs. So if we do it over here, we have to do it over here as well. Draw a line. We get 2x is equal to 15 minus 3 is 12. All right. Do I have any more addition or subtraction over here? I don't. So we're going to move up to multiplication and division. Do I have multiplication? Yes, I do. How do we undo multiplication? Remember, we want this leading coefficient to be a 1, so we're going to divide by a 2. If I do it to the left side, I got to do it to the right side. 2 divided by 2 reduces to a 1. So this is just an x with a leading coefficient of 1, and 12 divided by 2 is 6. All right, and that's your answer. And if you want, we can check this by taking this value and plugging it in for x. So now we have 2 times 6 plus 3. 2 times 6 is 12. 12 plus 3, does that equal 15? Yes, it does. Now, if I use GeoGebra to to graph the problem we just did, if you look down here, we actually have 2x plus 3 equals 15. Right? If I graph that, you'll see that I did get a line right here at 6. All right, and I can show the label there, the value, and we get x is equal to 6. That's the answer. So just to make a connection between what we're doing on the paper and what it would translate if we were to graph it. All right, let's take a look at another example. We have x divided by 4 minus 2 equals 1. All right, so we want to get the x by itself. We have to get rid of this 4, and we have to get rid of this negative 2. And we're going to do PEMDAS in reverse. So first we're going to deal with any addition or subtraction we have. Do I have addition and subtraction here? No, I have division. But here, I'm subtracting a 2. So what we want to do is we want to add 2. All right, keep the equations balanced. I have to do it to the other side. All right, and now let's simplify. We have x over 4, a negative 2 plus a 2 is just 0, so we're not going to write that, and a 2 plus a 1 is a 3. Now, any more addition and subtraction? Nope. Do I have multiplication? No, I do not, but I do have division. How do we undo division? How do I get rid of this 4? I'm going to multiply by a 4 over a 1, right? And these will reduce to a 1, and now I'll just x over here. Now, if I did it over here, I have to do it over here. Right, 3 times 4 is 12, right? And now we have x by itself. The coefficient's a 1, and I have just a 12 over here, so my solution is x is equal to 12. Plug it in over here to check. We get 12 divided by 4 minus 2. 12 divided by 4 is 3. 3 minus 2 is a 1. It does indeed check. Alright, let's take a look at 3 more examples here. In this first example, I have 99 is equal to 11 times x plus 7, which is in parentheses. Which is pretty important because although I do have addition here, it's inside parentheses. So we're going to take care of parentheses at the very, very end. All right. So the first thing we're going to run into is we have addition, but it's in parentheses. We're going to hold off. We have multiplication. We have division. Right. We have 11 times this. So we're going to divide both sides by 11. Divided by 11. 99 divided by 11 is 9. And now we have x plus 7. Since we have just an x plus 7, right, these will reduce. We don't have to write that in parentheses. Right? And now we're just left with, this is actually a one-step equation. We're going to subtract 7 from both sides, and we get 2 is equal to x. If you prefer, I know a lot of people like to do this, you can actually rewrite this as just 11 times x plus 7 equals 99. A lot of people like to see the variable on the left side, which you can do that, but it's good to get in the habit of seeing it on both sides and being able to do it on both sides. Let's look at the next example. We have multiplication here, we have addition here. So we're going to take care of the addition subtraction first. Subtract 10, subtract 10. And now we have negative 4m is equal to negative 12. Alright, and we're going to divide by negative 4. Divide by negative 4. A negative divided by a negative is that equals positive 3. Right. And the last example over here, we have a 3 plus a z divided by a negative 8. With a problem like this, you have to imagine that there actually are parentheses up here in your numerator. Alright, and once you do that, it's very similar to the first problem. We have to take care of this division first. So assume that there's parentheses up here. We don't draw them, but they are there. This whole thing is a grouped numerator. So what we're going to do first is to multiply by a negative 8 over 1. Multiply by negative 8. And we'll be left with, these will reduce to a 1. A 3 plus a z equals 2 times negative 8 is negative 16. Alright, and from there we're left with just a one-step equation. We're going to subtract a 3, and we get z is equal to negative 19. Alright, and remember you can check all three of these by plugging your values back into the original, your solutions back into the original problems.